Good afternoon. I am Dr. J. Prashad, working as an assistant professor in the Department of Electronics and Communication Engineering at KPR Institute of Engineering and Technology. Today, my presentation is focused on one of the applications of digital signal processing in biomedical field. A basic digital signal processor has three functional blocks, namely ALU, memory, and digital filter. So while we comparing all the blocks within the digital signal processor, only digital filter consume the maximum area, so that the overall efficiency of any digital signal processor is mainly based on the operations of digital filter. So that is why my presentation it deals with digital filter. And while we talking about the applications of a digital filter, the digital filter play a vital role in the area of signal processing, image processing, and many communication applications. So in which my presentation is deals with applications of digital filter in biomedical signal processing. And there are many biomedical signals are there. My presentation is deals with ECG signal. So the title of my today presentation is ECG signal noise removal. My presentation about these content only. So before we are going to discuss the demonstration of ECG signal noise processing through MATLAB code, I would like to address what is biomedical signal and the importance of biomedical signal processing and basic characteristics of a biomedical signal. Once we discuss these things, we are going to discuss the demonstration of an ECG signal through MATLAB. So what is biomedical signal processing? So which is the process of modifying or altering the characteristics of a biological signal. The biological signal is a kind of signal which convey the information about living organs and cells, and how that biological signals are generated is due to the potential difference across the cells or organs. Then the next question is, what is the need of biomedical signal processing is, by processing of biomedical signal, doctor can identify what is the actual disease that signal has, and based on the results identified by the doctor can give the diagnosis for patient, so the doctor can save the human life. And figure 1, it shows the list of basic characteristics of a biomedical signal, and that figure help us to identify or learn the importance of filtering application in biomedical field. The x-axis deal with frequency and y-axis deal with an amplitude voltage parameter. And here it is noticed that all the biomedical signal, the amplitude level between microvolt to millivolt, and all the biomedical signal during the acquisition, it has a noise frequencies. That noise frequency is about to be 0 to 0.5 Hz. So in order to further processing of all biomedical signal, it's require a pre-processing which including of amplification and filtering. Here in filtering operation, digital filter play a vital role in biomedical field. So here are some of the important characteristics of a biomedical signal. All biomedical signals are non-periodic signal. Since biomedical signal are not able to determine by mathematical equation or described by a mathematical equation, all biomedical signal is called to be a random signal. And what are the important characteristics? Here we noted is all biomedical signal has two different type of noises. It's called to be a baseline noise and power line interference noise. Actually these two noises signal has during the acquisition of a signal, and the baseline frequency noise is about to be 0.5 Hz to 0.6 Hz, and power line interference frequency is about to be 50 to 60 Hz. And all biomedical signal at least it require minimum 200 Hz sampling frequency and maximum 20 kilohertz frequency. So with this discussion we'll move to discuss what you mean by an ECG signal. ECG signal is a kind of biomedical signal which convey the electrical activity of a human heart, and ECG signals are generated due to depolarization and repolarization of heart muscles. And figure 2, it shows an ideal waveform of an ECG signal. It shows the normal patient ECG signal value. It has an 3 peaks, P, R and T. R has an highest peak, and the voltage level of ECG signal is about to be 0.5 millivolt, and frequency range for an ECG signal 0.5 to 100 Hz. and noted that P and T of an ECG waveform is exactly lies on baseline, and it has a two segment, PT segment and ST segment, and other parameter values are tabulated in table 1, and this is all about these all values about to be an ideal waveform, I mean normal ECG signal waveform. And these are the three noises ECG signal has during the acquisition. It's called to be a baseline wonder noise and power line interference noise and EMG noise. So let me discuss one by one. So first one, baseline wandering noise. This is occur in ECG signal acquisition due to the improper placement of an electrode, and sometimes that baseline noise occurs due to the moving of a patient during the acquisition, and the frequency content for a baseline wandering noise is about to be 0.5 to 0.6 Hz. And figure 4, it shows in a model waveform of how ECG signal is interference with a baseline signal. Here you can notice that the ECG signal here it is signal has a multiple ECG waveform and few part of an ECG waveform, like from time period 69 millisecond to 75 millisecond and 78 millisecond, 79 millisecond. In these part of an waveform, you can see that the ECG waveform goes down to the baseline noise, and this is occurs due to the improper placement of an electrode during the acquisition. So for further processing of an ECG signal, the first we need to be eliminate this baseline wandering noise. That can be do with the help of digital filtering. Figure 5, it shows the general block diagram for removal of baseline wandering noise in ECG signal. So how the process will be done is, the first step we need to be acquire an ECG signal that we can do with help of suitable electrode. Then since it is in a digital filtering process, the acquired ECG signal should be converted into discrete case. So for that purpose only, this next step we have a sampling process. As we discussed earlier, for any biomedical signal, for sampling operation, minimum it's require 20 Hz to maximum 20 kHz. Here I am choosing the sampling frequency as 360 Hz, and then we need to be choose the type of a digital filter. The type of digital filter what we have chosen is high pass filter here. The type of filter is Butterworth filter, and the cutoff frequency what we have set for high pass filter is 0.6 Hz. So basic reason is basically baseline wandering noise have a frequency range from 0.5 to 0.6 Hz. Then we need to be define pass band and stop band attenuation of a Butterworth high pass filter. I have chosen pass band attenuation is 60 decibel and stop band attenuation is 1 decibel. So let me discuss this. Let me discuss how that baseline wandering noise has been removed from an ECG signal through MATLAB code. Remember, for ECG signal baseline wandering noise removal, the first step we have to acquire the ECG signal. That ECG signal called from a database. Then next step of a signal processing is we need to be do an sampling. So as we discussed earlier, for any biomedical signal, at least it require 20 Hz for a sampling frequency at maximum of 20 kHz. But here we have chosen sampling frequency as 350 Hz. So according to the sampling frequency of 350 Hz, and these are the samples we acquire at the output end of sampling block. It has in a two column. The first column is about to be the number of samples, and the second column will be the respective voltage values, and these discrete values will be the input for digital filter. So let me discuss how that digital filter will be response for these discrete samples. So first I will show you the ECG signal waveform with baseline wandering noises. Okay, just remember, for ECG baseline wandering noise block diagram, the first block will be acquire ECG signal, then second block by sampler block. The sampler block will be produces the sample values of an acquire ECG signal in two columns. The first column is about to be an number of samples that I declare as X variable, and second column its respective voltage value I declare as Y value. Now I am going to run the program. And this is how the occur ECG signal looks like. Here we can noted that the ECG signal is the interference of noise signal, I mean baseline monitoring noise signal. Let's discuss how baseline interference signals will be removed from an ECG signal with help of digital high-pass Butterworth filter design. So before I am going to explain the MATLAB code for noise removal, I would like to summarize the filter specification. So this is the block diagram that I have applied for baseline noise removal. So first step we need to be acquire an ECG signal. That ECG signal, so since it is in a digital Butterworth high pass filter design, that ECG signal should be converted into discrete case. So that is why we have a sampler block. That sampler block sampling frequency I have chosen 360 Hz. I will show you the output of a sampler block. So which is an output for a sampler block. Here we can say that two columns are exist. The first column is about to be number of samples, and second column its respective voltage value. For filtering operation we need to be call voltage value, I mean the second column. This discrete values will be the input for digital Butterworth high pass filter design. So the filter specifications are: order of the filter is 50, and I have chosen 0.67 Hz for the cutoff frequency of a baseline noise. So why I have chosen 0.6 Hz is the frequency rating for baseline interference is 0.5 to 0.6. So that is why I chose cutoff frequency as in 0.67 Hz, and passband frequency is 0.35 and stopband frequency is 0.6 Hz. Now we will discuss the response of a digital Butterworth high pass filter design. So which is in a MATLAB code. As I said earlierly, the first step in design process we need to be acquire an ECG signal. So the line number 30 here I called ECG signal, and it is connected to sampler block. The sampler block output will be in a discrete case. So in sampler block output as in a two column, the first column is to be number of sample and the second column is the voltage value. For filtering application we need to be called voltage value alone. So that is why I called second column of a discrete sample value, and that should be is the input for Butterworth filter. So line number 31 here I called Butterworth filter from library, which is in a syntax for in a Butterworth filter design. Here H it indicate to be an high pass filter, and line number 28 it indicate to be general syntax of an high pass filter design. In high pass filter design we need to be define stop band frequency, pass band attenuation and stop band attenuation, and its values are respectively 0.3, 0.35, 60 and 1, and other specification like sampling frequency, order of the filter and cutoff frequency that we need to be defined. So once filter specification is defined, I am going to simulate the program. And this is how the output looks like. Actually the first figure it shows in a ECG signal with baseline interference signal. Here we can observe that the accurate ECG signal is interference within a baseline noise, the frequency between 0.5 to 0.6 Hz. That signal will be connected to an input for a digital high pass Butterworth filter design. The filter will be that a digital high pass Butterworth filter will be remove the frequency range between 0.5 to 0.7 Hz. So it will be give the responses like this. Here we can observe that the low pass frequencies between 0.5 to 0.6 Hz has been removed with the help of high pass filter design. Thank you. The next session we will discuss how power line interference of an ECG signal that will be removed. We will discuss in next session. Thank you.